Hey, my name's Sid, and this is my Orchid take-home assessment demonstration. I already uploaded all the code onto GitHub. You can take a look at that. And then I've also added a flowchart, which is basically the basic architecture of this project onto the README file, so you can take a look at that as well. I'll go ahead and explain some of the architecture right now. So our front end is entirely just Next.js React, and then it just takes in an input URL and spits out a clone of the website that the URL is linked to. And then we have our backend, which is Fast API, and our website scraper modules are pretty much just Playwright and Beautiful Soup. It uses it scrapes the main HTML, CSS, and JavaScript encapsulated dynamic rendering HTML. I'll get into that a little bit more. So our next step is just our prompt builder, which is just formatting the context for the LLM input, and then our LLM service, which is GPT-4, and then HTML back to front end, and just clones it and renders the HTML inside iframe or sandboxed preview block. I'll go ahead and open up VS Code right now and just do a little walkthrough of the code. I'll start with the backend. So here's our backend. It's entirely in main in our backend folder. And the first part of the backend is basically just cores, which is just resource sharing between different domains. This was already given, so I haven't changed that in any way. OpenAI API key, getting it from the .env file, which is right here. And then this is the pydantic modeling. That's also kind of given because a bunch of different methods were given. I had to remove some of them, and I only left the main one that's needed, which is just the clone request pydantic model. So I have two main parts into this, which is just cloning the actual website with just, this is just like the main function basically, which is calling all our other functions. So we have scrape website, which is kind of what I wanted to go over with a little bit. So I've used something called Playwright, which is basically taking into account for all the dynamically rendered or like dynamically constructed HTML. So there's raw HTML for a website, but there's not that much of it. When you click onto a link, the first thing that kind of happens is a JavaScript kind of tells to create new HTML basically. This is rendered on the fact that you open that link. And that's not showed with raw HTML, which is why I kind of moved away from general scraping with just Beautiful Soup or HTTPX. I wanted to use Playwright, or another option to use this would have been Puppeteer. So there's kind of two options with this. Use either Playwright or Puppeteer, and they both have two functions for the most part. Playwright is for the most Playwright and Puppeteer can both take screenshots of the URL. So you feed it a URL, it can go to the website, create basically a Chromium headless version of it, and then takes a screenshot of the URL, the main layout of the website. And then I was initially planning on using that into our LLM prompt right away, just to get a sense of the design, so that like LLM can get a sense of the design. But I think I veered away from that. I'll get into that a little bit more because I'll get into that later. So I'll go ahead and just walk through some of this code right here. So this is just our scrape website, takes in a URL, asynchronously has async playwright. And then this is kind of what I was mentioning earlier, a headless version of Chromium is launched with that URL. And then it just waits for the browser, which is a plus because since we said async for the function, we can use await. And we want to await for the browser's new page, go to the URL, has a timeout in case it doesn't open, and then just waiting for the load state basically. And then the next thing I kind of want to do was just grab all the rendered HTML. So here's just getting all the page content basically through Beautiful Soup. This gets all our raw HTML. And our Chromium, because we said with Playwright that we wanted a Chromium headless version, we will also be scraping out all the dynamically rendered content as well. And this is just for all the inline CSS styles. And then, yeah, just waiting for the browser and returning. And then this is kind of just our build prompt. So the prompt is the UR front-end developer AI, recreate a clean HTML clone of the following website, and then use only CSS, external images or style sheets, return the HTML content, nothing else, the DOM, CSS, and output a single standalone HTML page. This is clean LLM output, not only with the clone of the page. I was also getting the LLM's summarizing output, so I just used some regex to kind of get rid of that. And lastly, just calling the LLM. So the LLM is, we're using GPT-4, so we kind of just want to have temperature, which is just basically how wild our response is. So yeah, there's that. And then here's our raw output, and then scraping again for just getting rid of some of the summarizing content of the LLM. So I'll go ahead and just kind of go over the main takeaways from this project. One of them is that many modern websites use JavaScript to change or add content after the page loads, which is basically called client-side rendering or dynamic content loading. And that's one of the biggest things that I needed to take account for that I didn't do in the beginning of the project. So it was really important that I took account for all the dynamically generated DOM, basically. The DOM's just basically it's a tree of the structure of the HTML. Each tag would be a node. The next main thing I kind of had to take away from this project was that one, I mentioned this earlier, I kind of wanted to take a screenshot of Playwright, but the problem with that would be the token limit issue, which was something that I hadn't really taken account for at all until like today morning. When I was working on it, I noticed that with GPT-4 especially, there is a max amount of tokens that you can generate per API call, basically. So if I was to give an input URL of Apple, that would have way more tokens than the minimum amount of tokens that you can use, if that kind of makes sense. So I needed to account for that, and because of that, I had to basically not include a screenshot from Playwright because base64 encoded would increase the amount of tokens that are generated for that call substantially. And then I also had to make sure that I used just a simple HTML page for this, because I didn't want to get credits for GPT-4V, or maybe I could have used GPT 3.5 Turbo and got extra tokens for that. But yeah, so that's kind of something that I hadn't really taken account for in the beginning. But the code does work, and if you had some kind of professional account where you didn't have a max amount of tokens for a call, then it should definitely be able to clone Apple's website or any other website, really. So I'll go ahead and get into some of the front-end code right now. I won't go over too much. I think I don't know if there's a time limit, but I might have exceeded it already. So the main thing is just the fact that this is the entire HTML of the site. Yeah, just borders, just the design of the site overall. I'll go ahead and do a little demo of it right now. So first, I'm going to go ahead and 1 minute. Okay, I'm going to go ahead and run the backend server. And then I'm going to go ahead and run front-end server. And then give me one moment. Okay. So here's basically the site. I'm going to go ahead and give an example domain. This is kind of like the basic one I'm using for now, just so there's not too many images and it just takes clean HTML, CSS code. And it also includes the JavaScript like encapsulated code as well. So I'll go ahead and give the URL and then clone website. It takes a minute because it has to go through like the LLM response as well. But yeah, right after it's done, you can see that the site is rendered. I'm planning on making a small change, which is the front end kind of just like extends all the way and shrinks the site down to just this block. So if I can kind of just like end the bubble for this here and then have the new bubble come all from one end to one end, that's something I would change right now. But yeah, if it wasn't for the token issue, I would definitely be trying a more complicated site. But because some options for this, if you don't want to kind of change the model you have, is including token truncation or token chunking. Truncation is basically just basically limiting the amount of tokens that you can use, and then it kind of just like cuts the code right there at the point where the token kind of extends, if you know what I mean. Because this is just like, it's taking every single line of code and feeding it into the LLM, and that's a lot to handle. So that's kind of why the token issue is there in the first place. And then we got chunking, which is basically just like cutting down all the unnecessary code, really. But the problem with that is if you have a website like Apple, there's not really that much unnecessary HTML, CSS code that you can cut out without kind of ruining the integrity of the website itself. But yeah, that's pretty much my entire project. I hope you liked it. And looking forward to hearing back, I guess.